Welcome! In this video, we'll visualize how a non-competitive inhibitor decreases the rate of an enzyme reaction, and then we'll answer a cytoskeleton question. First, the question: how does a non-competitive inhibitor decrease the rate of an enzyme reaction? Choices: by binding at the active site of the enzyme, by changing the structure of the enzyme, by changing the free energy change of the reaction, by acting as a coenzyme for the reaction, or by decreasing the activation energy of the reaction. Here is the key idea. A non-competitive inhibitor binds at an allosteric site, not at the active site, and changes the shape of the enzyme. That change in shape reduces catalytic efficiency. Let's visualize the enzyme and its active site, the substrate, and the product. Now, watch the substrate bind at the active site, and the enzyme convert it to product. Now, a non-competitive inhibitor binds at a different site called an allosteric site, not the active site. This binding changes the shape of the enzyme and lowers the maximal rate, Vmax, but does not change substrate affinity, so Km stays the same. Watch the inhibitor bind away from the active site. Notice the enzyme changes conformation. The substrate can still bind, but the turnover is reduced. Let's see this on a Michaelis-Menten plot of initial velocity versus substrate concentration. With no inhibitor, the curve approaches a higher Vmax. With a non-competitive inhibitor, the maximal rate is lower, but Km, the substrate level at half Vmax, stays the same. First, the baseline curve without inhibitor. Now, the curve with inhibitor. We draw the original Vmax and the reduced Vmax, and we mark Km at the same substrate value for both cases. So the non-competitive inhibitor lowers the apparent Vmax by changing the enzyme's shape at an allosteric site. It does not bind at the active site, it does not change delta G, it is not a coenzyme, and it does not decrease activation energy. Therefore, the correct choice is by changing the structure of the enzyme. Next question: which of the following is not a known function of the cytoskeleton? Options: to maintain a critical limit on cell size, to provide mechanical support to the cell, to maintain the characteristic shape of the cell, to hold mitochondria and other organelles in place, and to assist in cell motility by interacting with motor proteins. We will build a quick visual to recall true functions. The cytoskeleton does provide support, helps maintain shape, positions organelles, and enables motility with motor proteins. It does not set a critical upper limit on cell size. So the function not performed by the cytoskeleton is to maintain a critical limit on cell size.